So projectile motions. First 10 question, as I mentioned, I have already recorded, so I will solve from 11 and onward. In question 11, a ski jumper leaves the takeoff platform horizontally with a velocity of 28 meter per second. It's better you just have a rough sketch of the question whenever you're solving related to directions or projectiles. So a ski jumper leaves the takeoff platform horizontally with a so she leaves it horizontally, so means she leaves like this with a velocity of 28 meter per second, as I mentioned, horizontally, and she lands 4 seconds later. So example, this is a point, she leaves the platform and after 4 seconds she hits the ground. So this is the point where she hits. We have to calculate the angle to the horizontal which she moved just before she lands. So what we need this angle, because just before she lands, we need this angle with the horizontal. Now to get this angle with the horizontal, what we need the two components of the velocity. Because what we will do, we will have the horizontal component and we will have the vertical component. So if I have the horizontal component of the motion and I have the vertical component of the motion, so after having the horizontal component and the vertical component, I will simply use the trigonometric ratio tangent theta to work out the angle. So how to get and she took 4 seconds to hit the ground. So how to get the horizontal component? Where, as you can see, it's a two-dimension motion. So we assume that there is no air resistance. In practical, there will be, but we assume that there is no air resistance. So as there is no air resistance, the horizontal component will remain same. So if she moves horizontally in the beginning with a speed of 28 meter per second, so what is the horizontal component? As she's landing, that will be 28 meter per second. So we have the horizontal component that we don't have to calculate. But what about the vertical component? As in the beginning, she moves horizontally, so initial vertical component is 0. Initially, there is no vertical component. The final vertical component is v. The time is 4 seconds. And what about when the object is moving in the direction of the gravity? So it will accelerate due to gravity, which is 9.8. So first, what we'll do, we'll find the vertical component. Initial vertical is 0. Final vertical is v. So how to work out the v? So we can use the equation of the motion like v is equals to u plus at. Where u is the initial speed, 0. A is the acceleration due to gravity. Why we did not take negative? Because it is moving downward. That's why it will accelerate. So you should take positive. If she was moving upward, then we'll take as negative. And the time is equals to 4. So this will be 9.8 multiplied by 4. What's the answer for V? The final speed, final vertical velocity? 9.8 times 4. 39.2. So this is 39.2 meter per second. We want the angle, we want this angle. So we have the final vertical 39.2. So it's a right angle triangle in which the vertical component is 39.2 and the horizontal component is 28 meter per second. And we need her angle, she hits the ground. We need this angle. As I mentioned, calculate angle to the horizontal just before she lands. So this was 28, this is 39. So we need the angle. We have this is the perpendicular and this one is the base. So we can use the trigonometric ratio that tangent theta is equals to perpendicular divided by base. So the tangent theta, the perpendicular is 39.2 and the base is 28. We need theta, so theta is equals to tan inverse. Whenever you're solving, like using a trigonometric ratio, your mod of the calculator should be in degrees, not in radian. So 39.2 divided by 28. What's the final answer for the angle? Tan inverse 54.5. So theta is equals to 54.5 degrees. So means she will move at an angle of 54.5 to the horizontal. But what if they ask what is the final velocity? So how to work out the final velocity? So you will use a Pythagoras theorem. You have the horizontal component and you have the vertical component. So you use the Pythagoras theorem like 39 square plus 28 square in a root. So basically a projectile motion is a combination of two motion, horizontal and vertical. Horizontal, you just use a formula, speed is distance over time. And the vertical, you will use the equations of the motion to work out the displacement. In a competition, the ski jumper ski down in run and then take off from the platform. So you can see the platform is there. They aim to land as far as possible along a downhill slope. The scoring based on the distance traveled by a ski jumper beyond the K point. Like how much distance they covered beyond the K point. Like this is the in run, then this is a takeoff platform, and then they land on this. So how much distance they covered horizontally beyond this K point, which is position 120 meter along the downhill slope. Before the competition begins, the ski jumpers have a practice run. If any ski jumper land too far beyond the K point, the initial start point of in run of a competition will be lower position. Like if ski jumpers are able to cross this point easily, so the K point is much lower, like the starting K point is much lower. Explain in terms of initial energy of a ski jumper why starting at a lower position will result in a safer landing. So, and it's a 4 mark. Basically, this is related to the conservation of the energy. So if they have a lower starting point, that will have, the question is, explain in terms of energy, initial energy of a ski jumper, why starting at a lower position will result in a safer landing. Because if they start with the lower positions, then they will have a lower gravitational potential energy. If they have a lower gravitational potential energy, the kinetic energy will also be lower. As a result, like they will travel less distance, or they will have the lower velocity at which they land or hit the ground, or so they will experience a smaller impact force. So you will mention when it is starting from a lower height, it will have a lower gravitational potential, means less kinetic energy, so which reduce the speed at which they land or hit the ground. So it will experience smaller force or lower impact force. The second part, a ski jumper leaves the takeoff platform horizontally, and we did this just question like calculate the angle. So we just calculated that was about 54.5. That was a question 11. I included that part. So we did this solution was there. This is what we have discussed, this part B. Now you can see the ski jumper receives 60 points if she lands at K point and 1.8 points for every additional meter. So if they land at K point, this is a K point, so they will receive 60 points. And but for additional 1 meter, for each 1 meter, they will receive extra 1.8 points. The downhill slope has a constant gradient of 35 to the horizontal. Determine the total point score by this for the jump. So that it's the same, like we have the takeoff speeds. So the takeoff speed was 28. So first what we will do, we will find what is the vertical height it will fall. Because see that this speed was 28 meter per second. They already mentioned it's a continuation of the question. And the vertical speed is 0. Vertical does not have any speed here. So first, and it is taking 4 seconds to hit the ground, land. So first we'll find what is the vertical distance it covered. Like how much vertical distance from the starting position it covered. So to get the vertical position or the height, what we use equation of the motion and the vertical component. If we have the time, so I can use the equation of motion s is equals to ut plus half at square, where u is equals to 0 because there is no vertical component of the velocity, or initial vertical is 0. So, and time is 4. So this will be 0 into 4 plus half. Acceleration is due to gravity 9.81 and the time is equals to 4. So this will give us the vertical height from the starting position from the platform. So when we multiply like 4 square into 9.81 divide by 2, so this will give us 78.5 meter. So this is 78.5 meters. Now what we will do, as we need the angle, as we have the angle, so we want how much distance it has covered, extra distance. Like this K point is 120. But now what we'll do, we'll find this distance to know what is the total distance it had covered on the inclined surface. So if I have the if I have the height, which is 78.5 from the starting position, I know the angle at which, because the inclined surface, this angle is there, 35 is given. So this angle is 35. So I need this distance on the inclined surface. So we can use the trigonometric ratios. Like this one is a hypotenuse for us, this one is a perpendicular, and this is base. So I have perpendicular and I need hypotenuse. So I can use sine theta. As we know, sine theta is equals to perpendicular divided by hypotenuse. So sine 35 is equals to perpendicular, which is 78.5, divided by hypotenuse, we don't know. We just cross multiply, hypotenuse will be equal to 78.5 divided by sine 35. So 78.5 divided by sine 35, this will give us the total distance, the hypotenuse of this triangle, which is 136.9. So 136.9 meter is the total distance which it has covered on the inclined surface. So how many extra meters it has covered? So if the K point is 120, if K point is 120 and this total distance which it has covered on the inclined surface is 136.9. So how much extra distance it has covered after the K point? So 136.5 minus 120. So that is equal 136.9 minus 120. So it will be 16.9 meters. So 16.9 meter is the extra distance which this skier or athlete covered. So 16.9 for each extra, the extra point for each kilometer, each meter is 1.8. So 16.9 multiplied by 1.8, so that will be 30.4. So 30.4 points will be extra after the K point. So till K point, score 60. And after that, 30.4 extra points will be there. So what are the total points score? It will be 90.4 points. Because to reach a K point, it will score 60. And after K point, every extra meter, it is 1.8 points. So extra meters, 16.9 are the extra meter cover. So 16.9 into 1.8, that's why it is 30.4. So 30.4 plus 60, that will give us 90.4 points scored by this jumper. Then the next question, calculation. The calculation in B assume the only forces acting on the ski jumper was a gravitational force. Suggests one other force that acts on the ski jumper and discuss how this force might affect the distance traveled by the ski jumper. So we assume that only the gravitational force or a weight of a ski jumper is there, that's the only force. But in reality, it's not like only force. In reality, there will be an air resistance as well, practically. So or there might be a friction, air resistance is there, or we can say drag or a friction, and that will reduce the velocity of both horizontal, like vertical acceleration will also reduce, and horizontal it will cause a deceleration. So as a result, it will cover a shorter distance. Like what we assume there is no air resistance, there is no air to oppose the motion. But what happened as the air will oppose the motion, so it won't land with the same distance, it will land in a shorter horizontal or a vertical distance as it start to decelerate horizontally. So it's a 4 marks. How you'll mention? What are the points you will mention for this one? First thing you will mention, there will be an air resistance or a drag will be there, and due to this air resistance, the horizontal component will not be constant. It will have a deceleration or it will reduce the horizontal velocity. As a result, it will cover a shorter distance. So it will land higher up, like likely position. If it is the vertical, this was 130, this was 78.5. So it will be shorter than 78.5. So both distances, the horizontal and the vertical landing positions will change. So question 13 and onward we'll do tomorrow.